I'm excited to welcome Liran Tal, Director for Developer Relations at Snyk. Liran, take it away.
Hello, everyone, and thank you for joining my talk. Are we forever doomed by software supply chain risks? If you joined this talk, it probably means that you care about software and you care about software security. Most of all, you are curious like I am, how does open source software supply chain security impact all of us? And so if you care about open source software security, then this talk is for you and you're exactly at the right place. Let's take a moment to reflect on this picture. When you look at this photograph, what comes to your mind? Is it a futuristic outlook of our world, or perhaps the uprising of our robot overloads? For me, I ask myself, how much does this robot in that picture learns about my child, and where does all of that information go to? Where is it stored? Is it stored safely? I think about things like, where does this robot get its software updates from? And well, is it possible that this upstream source of this software versioning, for example, can be compromised? What can happen if it gets compromised? What is the impact to my child and that sort of interaction? What is the probability that someone is able to just hack in through this robot situation and watch over the video feed or maybe interact with my child? These are some of the things that keep me up at night, and they're all related about software supply chain security concerns. So today, I would like to share with you some real-world stories of, first of all, how developers play a fundamental role in recent and growing security incidents, why you should care about software supply chain security, and leave you off to think about where do you put your trust. Let's get started. In case you had a doubt, we're seeing more and more open source software being developed. Year after year, open source software repositories are growing with more and more open source software footprints across different ecosystems. They're all growing. Java, Maven, Maven Central, NPM, NuGet, PyPI, they're all growing all the time. More of us software engineers are getting accustomed to the ways of open source software community contribution. More of us are becoming maintainers of open source software, collaborators in one way or another. That growth of open source software doesn't come without any risks. We're continuously witnessing the growth of security vulnerabilities in open source software ecosystems like NPM, like Java, like others. These are everything from CVE-based security vulnerabilities that need to be addressed by those of us who may be impacted by specific package versions, and all the way out of those normal regular security vulnerabilities, all the way up into incidents of malicious packages hitting everything from the software supply chain, like NPM registries, like GitHub repositories, like actions, like CI/CD systems, compromising all of them, and essentially making all of that malicious impact back into us, into developers, targeting us who rely on open source package ecosystems. Funding for open source software projects is typically dire. In 2019, developer Andres Stoltz collected data from Open Collective and GitHub to assess project revenues. Over 50% of projects could sustain their maintainers above the poverty line. That's kind of where it is. The OpenSSL, as an example, the OpenSSL Software Foundation has just 2 supporters under its corporate sponsorship program. Each of them is committing around $5,000 each. That's about it. It also picks up some donations via GitHub sponsors. That's for OpenSSL, which is a software project that powers the internet. But what do we mean when we say this is critically important? Well, let's see. What does critical infrastructure look like? For example, the cyber attack forced the shutdown of US's largest oil pipeline. That happened. The thing is, as we learned by Thompson's Trojan horse story dating back from 1984, developers have been targeted as a vehicle to distribute malware and backdoors for a long time. Now, let's explore some of these incidents like this Thompson story. Let's rewind back in time to get an early glimpse of how one developer perceived risks of open source software way back then, when open source was just starting out. We're talking about 1984. The Turing Award-winning Ken Thompson wrote a short essay titled Reflections on Trusting Trust. In this paper, he describes how he added a backdoor to the Unix C login program. Then he went on and continued to add a backdoor to the C compiler that compiles the login program. But then if someone looks at the compiler code, they may find it. How do compilers get to compile programs? Well, you need to compile the program. So he then further continued this chain of attack by essentially ending up backdooring the compiler that compiles the compiler of the login C program. That is the top of the chain where he added that backdoor. And this revelation of how software can be taught, essentially, like to learn specific traits, then he passed them on to their spawns, their programs that get created out of them. He explains in this paper how software can essentially remain without a trace of a Trojan horse because of the dangers that people put their trust in specific areas. They may trust the C login program. They may trust the compiler code. If they don't trust the compiler code, maybe they trust the compiler that compiles the compiler code, and so on and so on. So everything from the application code and all the way up to the compiler, the assembler, the CPU, my keyboard, my mouse here, this camera, everything comes from somewhere. That is essentially the supply chain. And we have to put our trust somewhere. That is the risk that we are taking. These are the risks day to day. Let's talk about the event stream, more and more real world stories. Event stream incident. Back in 2018, the JavaScript ecosystem witnessed its first high-impacted, spearheaded surgical attack targeting maintainers and developers working in open source, and themselves being used as an attack vehicle to distribute malicious JavaScript code that was designed to decrypt itself and run in a specific environment targeting developers of a Bitcoin wallet application. This was the well-known event stream incident, and I highly recommend going into it, reading the whole thing. I'll give you a brief here of summary of events of what happened, basically a post-mortem. Event stream started and existed on NPM JS registry since 2011. Practically didn't receive any new releases in the last 2 years of this incident happening, but it gained millions of downloads per week. Out of the blue, a person shows up on a GitHub repository, opening an issue and wanting to help, as is customary in open source software. They further contribute code with several pull requests, open issues, and then they also create another pull request that adds a dependency into event stream owned package dependency tree that they control. It is supposedly with a genuine intent to improve the code base for event stream. But a few weeks later, they added a code payload inside the dependency that they added now to event stream, which injects malware into a specific Bitcoin wallet application called Copay. That Copay wallet application used event stream as part of its build system for the application itself. And so now all the developers on their machines in the CI building this Copay app and using this open source event stream dependency are now being tainted by this malware, because essentially downloading now new versions of event stream would actually give you the malware and the backdoor in it. This had gone unnoticed for almost 3 months, resulting with 2 versions released of the Copay Bitcoin app. That, of course, included the malware. This is where we ended. An academic research paper published in 2019 investigated these properties of language-based software ecosystems and found that 61% of open source packages on NPM could be considered abandoned because they did not receive any release in the prior 12 months, showing us how event stream package would have been classified, for example, as an abandoned package in such research. Indeed. As if we didn't learn anything from the event stream incident, 1 year later on the NPM.js ecosystem, another JavaScript project called Electron Native Notify, that incident took place. What happened? Let's see. Very similar. At one point in time, an existing version of Electron Native Notify has no malware in it. It's just a fine package. It does what it does. A user adds to it a dependency tree to, a package to one of its dependency tree versions. Then that user goes on to release a new version of the Electron package, which now includes the malware. The result, the Agama crypto wallet, is built with the most recent version of the upstream EasyDex package that now includes the malware. Sound familiar? Exactly the same thing 1 year later. This security incident also took place in the real world. So going through all of this, essentially what we should learn that supply chain security is existing in different places. But wait, is it just the JavaScript ecosystem? Is it just web developers? Let's see. Another story. This is the sour mint malware. Software supply chain concerns aren't just open source related. Actually, we have witnessed it extending to mobile app store ecosystems. This is from a Snyk-led security research in the CocoaPod's mobile applications ecosystem, identified a malware in the Mintegral Ad SDK. This is the story of one Mintegral mobile SDK that is used for advertising attribution for mobile applications and was downloaded more than 1.2 billion times a month. It is integrated into 3,000 applications. These downloads are all of us, users of various mobile applications that their developers are using this mobile SDK, downloaded from official App Store sources. What Snyk found interesting is that this SDK had proprietary obfuscated piece of code hooked into sensitive and careful system APIs on mobile operating systems, which shouldn't be commonly used. So this really alerted a potential suspicious behavior, which Snyk also started investigating and looking what was going on there. So what did it essentially do? It intercepted all HTTP requests, and then to avoid detection, the SDK detects things like debuggers and jailbroken devices. And lastly, Snyk found that the SDK installs a backdoor used as a command and control remote instance for anyone else all over the world to just use. Now, this has to be something that we think about very, very deeply. How much thought are we giving to the security of our own development infrastructure? Resources like our cloud instances, our staging environments, our build and continuous integration tooling, which we as developers use as a daily basis. Here's a story. In January 2021, a security researcher broke into Microsoft Visual Studio GitHub repository. I use Visual Studio Code. It's an amazing project. It's an amazing idea. I love it. Essentially, in this research, the security researcher, what they were able to do is that breaking into the repository has essentially provided him with the capabilities of making code modifications to the popular and very well-loved IDE, just like me and a lot of other developers here. So how did it happen? Due to a command injection flaw that was made possible as a valid attack vector of a regular expression. Who doesn't like a good regular expression? So simply by opening a new code pull request, the researcher was now able to execute code that the VS Code CI scripts were running without requiring any sort of authentication or authorization checks. Now, this essentially led to remote reverse shells on those CI servers running in the cloud. And from there, basically the ability to gain push and write access to the repository itself, to modify the source code, to alter and send new commits into the Git underlying source code versioning system. Fortunately for all of us, this researcher responsibly reported this flaw to Microsoft before any advanced threat we know of, threat actors could exploit it. So this got closed. I would say, unfortunately for us though, not all supply chain security attacks end up in responsible disclosure, and some of them hit us hard, like really painfully. So was the case of April's 2021 disclosure of CodeCov's supply chain security incident. On April 15, 2021, it was reported that an unauthorized access to a Google Cloud storage key allow the malicious actor to alter the version of CodeCov's bash uploader script. Now, CodeCov, if you haven't heard of it, is a code quality tool used by many developers. I use it myself in some of my projects. It's a very well-known project across the JavaScript ecosystem, but also across other language ecosystems. And it is used to allow developers to assess code coverage and other code quality metrics. So it's a very essential tool for us. So we can learn about the extent of this incident from the Security Week opening note, which is security response professionals are scrambling to measure the fallout from a software supply chain compromise of CodeCov bash uploader that went undetected since January until, I remind you, April 15th, from January, and exposed sensitive secrets like tokens, keys, and credentials from organizations all over the world. How did CodeCov learn about the security incident involving the malicious bash uploader script? Well, on April 1st, a customer reported that the SHA-1, the SHA-1, basically the integrity signature used to sign the bash uploader, was not matching the one that was actually downloaded. So something is probably off. And so the impact was real and painful. This indeed confirmed the case. Organizations like both Twilio and HashiCorp that were impacted by this released statements of data leaks due to the CodeCov quality tool that is essentially used by developers in their CI, continuous integration systems, impacting all of us. How much do we know about the current state of open source security and what it entails? In an effort to explore the security awareness of the Python and JavaScript open source ecosystems and communities, a group of researchers investigated how maintainers work in open source community with regards to their ability to mitigate security vulnerabilities. One of the research questions was, how quickly do open source maintainers mitigate a newly published security vulnerability? Well, the research found that it takes about 100 days on average for both JavaScript and Python maintainers to start mitigating a public vulnerability, a publicly known vulnerability that is disclosed to them. The question is that fast enough for you as a consumer of a given library? And if we examine the number of commits that mitigate a vulnerability, out of the total number of commits that we can see, Python has more consistent track of security mitigation, whereas the JavaScript community was largely inactive in this regard until 2018. So this research and this specific insight kind of demonstrates the low levels of AppSec awareness around the JavaScript open source ecosystem in these early years before 2018, before it became more prevalent and known as vulnerabilities are part of your day-to-day activities, responsibilities. As a case study, we can actually refer to Mark's own security vulnerability from several years back. Now, if you haven't heard of Marked is a markdown parser for the web. It means that it can help you take in markdown syntax and push it out, parse it out as HTML and push it out to a web page. It is downloaded millions of times a week. One of the most popular libraries for these purposes in the JavaScript and NPM ecosystem in general. But one day, a security researcher opened a code pull request, which reports and fixes an XSS vulnerability. That pull request also added tests for future code regressions, so like we can find them very quickly if that happens in the next version, as well as proof of concept examples showcasing what this cross-site scripting vulnerability can actually turn into. How can it be used? Except, as is with open source software, maintainers are really just trying to do their best, but they can't be there all the time for all of us, right? There are no legal or contracting obligations for them to actually support us. So this vulnerability was left out in the open with no fix for a whole year. The security issue and proposed code fix was open in 2015, but was only merged and made available as an official release in 2016. Showing you how far and how long does it take for a security vulnerability to get fixed in an open source ecosystem. One case, there are many others that are much better, but this is one case, and it's enough to be that one case of millions of downloads, millions of users impacted that may impact us as well. So who do you trust? When we're all so very much dependent on open source software, and we can't ignore the question of where do we put our trust? Where do I put my trust as a developer? And What are some mitigations and security controls to help us cope with the risk involved? In 2017, a security researcher working with the Node.js Foundation conducted a research in which he wanted to assess the state of weak NPM credentials used by maintainers and developers on the npm.js registry. His work revealed devastating truths with regards to developers' lack of security hygiene to their accounts. For example, this security researcher was able to gain publish access to 14% of npm.js ecosystem modules. Some of these modules are downloaded tens of millions of times a week. They are an essential key part of this thriving JavaScript ecosystem. The problem was rooted with insecure passwords chosen by well-known maintainer accounts, actually. For example, literally the word password as an account password for a maintainer, which had a package that received millions of downloads. That happened. What could have happened if this was a malicious actor doing this? Instead of a white hat hacker, a security researcher. I'll let you think about that while we move to a different item. For code packages can reach thousands of millions of developers, shouldn't we have more protections in place? For example, as citizens of open source communities, can we do better to improve our own security of the account hygiene that we have? Let's see. npm.js, the largest registry of open source software packages, spanning 1.5 million packages to date. I think it's 1.7, 1.8. It's growing all the time. Open source is growing. It's supported two-factor authentication since the end of 2017. Despite all of the security incidents, compromised accounts, awareness that we're doing, right, like this talk, right, about how important security is, how important the supply chain security is, happening throughout all of those years since 2017. In 2019, only 7.1% of NPM package maintainers have enabled 2FA, only a 2% growth. Unfortunately, the software supply chain security story isn't resonating with developers because in 2020, 2FA enabled accounts have only grown by merely 2% to approximately 9% of developer accounts on NPM. So 2017, 2019, and 2020, we're seeing an increase from 6 to 7% to only about 9% of all NPM accounts. These days, npm.js has actually went through a campaign of forcing accounts of top modules maintainers, the first 100 and the first 500 and the first 1,000 of modules, the top modules on NPM, to actually force the use of two-factor authentication. And that is the direction that we need. And we need everyone across different ecosystems to do the same, to ensure that the supply chain security actually exists to protect all of us. So can we really deny being a part of an open source ecosystem? As consumers, contributors, collaborators, maybe even maintainers, we all play a part in a world where 90% of application code that we build is made up of open source components. We reach the point where we take open source for granted. Open source registries are open in their nature and allow developers to openly push their packages to them. What happens when maintainers pull the rug off of our feet and stop maintaining a library, or worse, completely remove a library altogether? That is exactly the story of what happened in 2016 when a maintainer pulled tens of their open source packages from npm.js. One of them was actually a pivotal package called leftpad that essentially broke a lot of builds over the internet, and many projects and CIs during install processes just broke down. At the very least, this incident showed us two things. One, the weakness in how businesses fail to manage their open source software in a good way. And secondly, how registries did not foresee this as a problem and so were not designed to handle these circumstances. What kind of malicious activities and assets can we track back to open source ecosystems? Time after time, we find more and more malicious packages hitting the NPM ecosystem. Misspelled packages, typo squatting attack, perhaps someone planted that as part of my nested dependency like we've seen with event stream and other incidents that we've heard about. How about malicious packages that are not just hitting us on the JavaScript ecosystem, but are also part of the PyPI registry and impacting Python developers as well? To further show us how attackers can harness open source to their advantage, we have this research from Alex Bershon just back in February 2021 about how we exploited design flaws in package managers, registries, and human error to infiltrate into corporations such as Apple, Microsoft, and others with this research. So I would like to leave you with the following questions to ponder upon. Are we going to have less or more software in the future? Are we going to use less or more software in the future, more open source software specifically? Who do you trust? Well, thank you for coming to my talk. I hope you enjoyed the event. My name is Liran Tal. I'm a developer advocate at Snyk, where we build a security platform to help developers build securely with open source software. Thank you again for joining and have a great time.